everybody. Glad you could make it today. This is the second presentation we've got concerning our new pest here on the island. Today, we're going to have a couple of speakers along that field. The first one is going to be Dr. Kieth has worked as a research plant pathologist for the USDA Agricultural Research Service in Hilo for over 18 years. Her research is focused on the biology detection and management of invasive pathogens causing disease on crops grown in Hawaii. Lisa attempts to develop and deliver practical disease management approaches that can be adopted by growers. So I think it'd be advantageous for all listeners to see what she has to say. So Lisa, you're at bat.
Well, thank you very much, everyone. Good afternoon. Thank you for the opportunity to share some information. I will go ahead and share my screen. And I'm just curious, do you see my cursor moving on my slides?
Yes. Yes.
Okay. Okay. So thank you once again. I appreciate the opportunity. What I tried to actually do is just put together as much information as I could to present our new unfortunate pest, coffee leaf rust. Okay. Okay. First and foremost, I just really want to say thank you to everybody. It's a collaborative effort from day one, and I look forward to continuing to work with everyone. So for the talk today, I thought I'd go over some broad concepts and start really with the distribution and history of coffee leaf rust, go into the biology, talk about the disease cycle, what it looks like, the symptoms on the plant, the signs of the fungus, how it behaves in the environment, how it contributes to damage and loss, the potential for managing it, and what we're starting to see in Hawaii. Okay. I guess it's the good and the bad that coffee leaf rust has quite a history. It was first identified in 1861, and you can see the timeline as it first went into cultivated coffee in Sri Lanka in 1869. It spread into Africa and Asia in the 20s, became widespread in Papua New Guinea in 65. It moved in and was first discovered in Brazil in 1970. Unfortunately, really rapidly spread into South and Central America, Jamaica, 1986, and most recently, the end of October on Maui and on Hawaii Island. So to talk about its biology, the fungus is called Hemilia vistatrix. Basically, it's named Hemilia with the half smooth spore. That's what you're seeing here, and the devastating nature. And these are very unique spore shapes for rust. Okay, so these are the Uridinia spores you're looking at. And to me, they look like, in a way, this taco shape. And it is covered with these spines, except for the bottom portion. Okay, so if you're looking here, you see the spines protruding all over. Now, this rust is an obligate parasitic fungus. So that means it needs a living host to survive, okay? So coffee leaf rust, coffee is the only host. As of yet, there's no alternate host, either necessary for its life cycle, for the rust to complete its life cycle, or actually causing a problem on any other host. What happens with this rust is once the spore lands on a leaf, it waits until the conditions are right in order to germinate. Okay, now we're looking at the life cycle. And if you start here, so these are the Uridinia spores. Essentially, the Uridinia spores travel, they land on a leaf, usually the underside. They need the certain amount of moisture to germinate. Once approximately 24 to 48 hours of standing moisture on the leaf is present, the rust can germinate in about 5 hours. It actually, the germ tube travels along the surface of the leaf. It finds the stomates, it starts growing mycelium into the stomate, essentially anchors itself into the host tissue. Okay, this is when now it's obligate. These feeding cells are essentially starting to now suck the life, the nutrients out of the plant into the fungus as it now grows and sporulates. So it starts as a Uridinea spore. It colonizes, it produces lesions, which produces more Uridinea spores, which actually are erupting out of the stomate. Okay, so this is different than other rusts. There's no pustule involved. The rust goes into stomates and actually grows back out of stomates, producing more spores, which then can continue the disease cycle more than once in a coffee growing season. Okay, so as far as this disease cycle, spore dispersal mainly occurs by wind for long distance and rain for short distance dispersal. And splashing rain is shown to be an important means of local dispersal. And it typically starts the infection, again, through the stomata. You have to have free moisture. There's a wide range of temperature, but there's an optimum for growth of the fungus. Once the spore lands, it germinates, it infects. Approximately 2 weeks later, new spores will develop through that stomate. The lesion will start to expand over a number of weeks. And the devastating part of coffee leaf rust is that the single lesion will produce many spore populations that can release hundreds of thousands of them back into the environment, which can just perpetuate the disease cycle. So the survival of this fungus is mainly the mycelium in the living host tissue, which in a way is a good thing. Premature defoliation, leaves fall off, most of the fungus will die. But unfortunately, if there's green leaf material, the Uridinea spores can survive approximately 6 weeks on their own and then usually be splashed again to start a new infection.
Mr. Okay. Freerose, how are you?
Someone needs to mute. But to continue, you can see the influence of climate and weather every step of this life cycle. For dispersal, it depends on wind, rain, and even harvesting and movement of picking. Okay, when it's deposited onto the leaf, how big and how healthy is the leaf. When it germinates, it depends on temperature and wet, the moisture, the radiation, etc., etc. Every stage is critical. And as we say in plant pathology, you have to have the right environment. So you can have those coffee leaf rust spores, you can have a susceptible host, but without these environmental conditions, optimum for disease, we may not get disease occurring. Okay, so I tried to incorporate some pictures along with just trying to better understand what we're trying to deal with here with coffee leaf rust. Okay, symptoms are actually how the host responds to pathogen attack. The signs are the physical presence of the fungus. Okay, so in A, this is the first symptom on the leaf. Again, the fungus is essentially taking nutrients away from the plant. So chlorosis, small chlorotic spots are the first visible symptom, usually on the upper portion of the leaf. On the underside, this is where you will see the start of spores, the spore formation of these Uridinea spores. And as time goes on, more and more spores will be produced, okay? They can be a variety of colors. We tend to see the orange quite yellow here, but it can vary from region to region, Okay, now this is kind of important because people are asking, well, what does it look like early? And it can be very confusing. So I found some great pictures by Jacques Avellino's group. I know he will be speaking to Hawaii next week, but I thought this was a good set of slides to show because this is actually the same leaf over time. Okay, this is what is considered minimal, but the start of infection. And you can see it's tiny chlorotic spots right at this stage. Especially if you held the leaf up to the light, you would see these small chlorotic spots, but there's no spores yet. Okay, that's what you're looking here at the top left. Now, as the weeks are going on, approximately a couple weeks from here, this is when you start to then actually see visible Uridinea spores, that powdery looking spore. But as you can tell, there's no pustule. Again, it's not this erumpent fungus coming through the leaf, busting through leaf material. It's coming back out of the stomates, and over time they will expand and produce more spores. And at this stage, approximately 2 months later, this is the older necrotic areas of some of these original infected areas. But it takes some time for this type of symptom to develop. Okay, so lesions can develop anywhere on the leaf, but they tend to be concentrated on the outsides where the moisture, the rain or the dew actually will collect on the leaf. And the centers will dry and turn brown, okay? Early in the season, they tend to see, at least elsewhere in the world, the lowest branches infected first. Okay, again, the material usually starts perhaps on the ground, it's splashed up, it starts the disease cycle, and as more spores are produced and the environmental conditions warrant, they start to spread, mainly the localized spread through water splashing. Okay, it can get quite severe if not managed. Again, the leaves prematurely drop and these look like twigs devoid. In a sense, this is ridding a lot of the inoculum, especially if sanitation can occur with what's on the ground, okay? Race and the level of inoculums, the most important factor for the pathogen. There are more than 50 races currently known around the world. Only a few occur regularly. We currently do not know what race is in Hawaii, but we should have information shortly on that. In addition to just the genetic makeup of the race of the fungus in Hawaii, okay? That will indicate if it is a recent introduction and a single introduction. Some important factors, how the planting density, how the host susceptibility, and the predisposition of the host, particularly due to the health of the plant. So a lot for this season will affect what happens with the disease next season. Okay. In order for me to make sure I have enough time to I'm going to go over some of this information pretty quickly. But again, the fungus is reducing the photosynthetic capacity of the leaves, okay? Oftentimes, berry growth and size are reduced. The impact not only affects the season we're in, but can have a long-term effect if it's not managed, okay? Worst case scenarios, trees can die, but that's not usually the case with it's definitely not the case with management, okay? Let's see. It has to be managed as a continuous epidemic. We have to be proactive. There are things to do to keep, your plants healthy. Spray protectants in combination with other fungicides. So ultimately, we're trying to reduce the sporulation and the dispersal to mitigate the epidemic, okay? As it says, good cultural management is vital, okay? The healthier the plant, the better. But unfortunately, there's no simple rule or silver bullet to suggest, okay? The type of variety, the nature of the soil, the amount and distribution of the rainfall, numerous other environmental conditions all interact to dictate what happens with disease, okay? But as far as nutritional status, the susceptibility of the plant can be affected, actually more susceptible with nitrogen and phosphorus actually reduces the susceptibility, and excessive potassium can increase susceptibility. Now, because moisture is necessary, pruning and training of the coffee plants, trying to prevent overcropping, helping maintain vigor will reduce susceptibility to the rust. Anything that can improve air circulation to promote rapid drying, again, to stop that standing moisture on the leaf, which is critical for the sporulation, the spores to actually germinate, okay? Weed control is important. It's also important, like I mentioned, these premature leaves that fall that have a lot of those spores on them should be removed from the farm. The role of fungicides is important. UH and Andrea, there's a guide to look at, but it is critical that, you don't want to overspray, and in particular copper can be detrimental for the environment, and we definitely don't want resistance building up in our rust population. And then of course, certain cultivars are more susceptible than others. Okay, I guess on the bright spot, there are natural enemies of coffee leaf rust. This is a picture, a fungus called Lecanicilium, which is now, so if you see, these are lesions, the rust lesions, and these are the spores, the Erdinia spores of coffee leaf rust. But this white covering is actually this other fungus that is essentially combating against the spores. And in some parts of the world, fly larvae actually start feeding. Now, while this is great, this really isn't a tool, one tool that could manage coffee leaf rust, okay? So I apologize for kind of going speedy, but I know Luiz will also have a lot to say. I only have probably a couple minutes left. But I wanted to show, so these are actually pictures we've taken of coffee leaf rust in Kona, okay? Just to try to zoom in and show you what we're trying to describe as some of these very initial chlorotic spots on the leaves, which are too small to actually have spore production associated with them. As they're getting larger, you start to see, this is what you're looking at under a dissecting scope, this powdery dust. And it's funny, one of the coffee experts mentioned, oh, it looks like Cheeto dust on the bottom of these leaves. And then these are indicative of the older lesions that have actually become necrotic in the center, but they continue to expand and grow. The fungus is still alive and growing and producing more Erdinia spores, which is what we're looking at here. So these are actually pictures of spores found in Kona. You can see the spikes associated with them. It's kind of a matrix on the outside, the yellowish color that we're seeing, and the smooth portion of the spore. Okay. It has been very confusing, even for trained eyes with microscopes. So what I wanted to do was share some pictures, which is not coffee leaf rust, okay? The most confusing, okay, so no, this is not. No, these types of necrotic, with this almost gray, no. These are the ones that can be very confusing, okay? However, these are really the start of Cercospora spot, a whole different fungus. And if you remember the earlier picture, there's no necrotic spot in the early lesions of coffee leaf rust. Okay, so that's the big difference when you're looking at these tiny, tiny spots that maybe look like that. No, so even that, no. If you look at it a bit more closely, it's not yellow, it's actually brown, necrotic. And on the underside of the leaf, you actually tend to see tissue Okay, so left side, coffee leaf rust. And again, just the start. So you can see it is just a small chlorotic spot that otherwise, okay, looks, there's no necrosis, no brown associated with it, and there's no indentation, there's no concave nature, there's no pustule busting through this leaf tissue. But you can start to see under the dissecting scope the spores being produced. Okay, this is the big confusing Cercospora spot. And the early, while yes, it is looks very similar, but if you look more closely, you tend to see a protuberance or slightly sunken nature, definitely with not the right color, and oftentimes this tiny necrotic spot. So I will summarize and definitely be able to answer questions after Luiz gets a chance, I think. I guess the summary, what can we say? And, you know, I always love to look on the bright spot. Coffee leaf rust has been around for 140 years. Okay. We are not battling something brand new to the planet like some other diseases I've been involved with. So there is a plethora of information and expertise around the world. It is well studied and is well managed. Okay. For Hawaii, we really need to determine where is it, okay, what race is it, and what is going to work best for management here in Hawaii. As mentioned throughout all of the literature, healthy plants are key, okay? If it's a sicker plant, it predisposes it to infection, okay? The ultimate goal is to recognize it early, to help eliminate inoculum and minimize the spread. So collectively working together, we can determine the environmental conditions and the various microclimates, temperature, rainfall that occur here, and what it means for the disease cycle as it progresses. So I thank you very much for your time, and I'm happy to answer any question.
Thank you, Lisa, very much. Appreciate that. That was pretty informative. I learned a lot on this one.
Good, thank you.
And like I said on the chat there, if anybody has any questions, please just put them in the chat on the bottom of the screen. There should be a little chat button, and you put in your question, and depending on how much time we have at the end of this, we will see about getting them all answered. Okay, and our next speaker is Luiz Aristazabál. I hope I pronounced it correctly. I met Luiz probably 6 years ago. I don't know how long he's been here, but he was one of the first people that jumped into the CBB issue. I guess it was longer ago than 6 years, but seemed to be on top of it now. He's got more pests to work with, keeps them out of trouble. So he's with SHAC, and he's quite active. I know he's been out to my farm several times and explains a lot and is very much down to earth. So without any more to do, I'm going to turn it on over to Luiz. Welcome, Luiz.
Okay, good. Okay. First of all, thank you to John, and thank you all Coffee Grower and Coffee Farmer Association, Kona Coffee Farmer Association, for the invitation. And also thank you to all of the institutions here in Hawaii that we are working in coffee, with support of the coffee industry. I really want to thank all to give me the opportunity to be here and keep addressing all these kind of the issues in coffee production. So I'm going to try to open my screen. I don't know if you can see. You can see right now? I don't know.
Yes.
Yes.
Okay, so let's go to a start. I don't know. Now it's much better. Okay. So this is the topic that I want to address today. I don't know if this is good or is bad, but this is the reality that we had to face right now. So the coffee leaf rots and alternatives are managed in Hawaii. So I put focus in what I know from my original country, Colombia, and a lot of information coming from there, also from other countries in South America and Central America. And I want to, at the end, to get some like kind of recommendation, what we can do in short term and in long term. So let's go to start. Like Lisa had told before, a very good description about the disease. I don't want to enter in detail of this one, but you get here like similar information, just maybe some small changes, but it's almost the same. The important thing is like this disease had to work in a coffee plant that they are susceptible and they had to be alive. So this is important to know. Coffee loss production could be between 10-50%, in some cases higher than 50%. And we had here all the coffee plant material that they are susceptible to this disease, starting with Typica, Caturra, and other that we already had here in Hawaii. And like Lisa had told before, at the beginning, it had to be opposite picture, sorry for that. But at the beginning, we just see starting to disease, just a little yellow color. And then this is the major signals that we can see, this kind of the orange or yellow or reddish ponder. This is like the most important signal when we go to the field and to say, okay, is the rot. However, it's very important also to, when people is going to take the samples, people from the agricultural department of Hawaii or University of Hawaii, it's very important. They are going to do like the confirmation on the laboratory, because they had all the keys to prove this one. But right now, this is like how to look in the leads. So the most important thing is all the factors that are going to make a positive or negative the condition for the development of the disease. So I put here 4 elements that are major factors. We start with the the pathogens. This is the coffee leaf rots is there right now. This had to be one of the rays that is going to attack susceptible coffee plants. So that means not all the rays are going to attack all Typica or all Caturra. No, there is some races that attack some cultivar, other races could be attack others. So it depends what we get it. Now we had plants, coffee plants that they are susceptible, Typica, Caturra, and others. And now we had 2 elements for the development of the disease. And then we had, this one is very important. What is the environment? What are the weather conditions? How all of these weather conditions are going to play in the growing and development of the disease in positive or negative way. And finally, the most important as well is how we are going to work, manage the coffee plantation. So all of these 4 elements are related and depend on the many conditions, specific weather conditions, susceptibility of the coffee plants, and how aggressive could be the rate that we have right now. This is how we are going to do, we are going to see in short and medium term, how the infection and severity of the disease is going to work here in Hawaii. We don't know right now, and it's something that we have to learn together. But human is very important factor, because it depends on us that we can act in advance and we can be proactive and try to do any kind of work we can do to keep our coffee plant healthy. And I think we can deal with this problem. It's a really big challenge. And I think it's not impossible to try to control, to keep this disease under control. Just is very challenging. Okay, let's go to see. This is the cycle. Lisa already told about that. I just want to mention that over the year, all the the different stages start with dissemination, germination of the spores, colonization, and reproduction. And over the year, this cycle could be about 6, 8, or 10 times. It depends on the location. And the time that is going to take between start dissemination to produce new spores could be between 28, 60 days. And this depends too much on temperature. So there is, like Lisa told before, there is some specific condition for every single stage. If for germination, we don't have water, is no way the spore is going to germinate. So need water and need darkness. It's like mandatory for them. And let's go to see this one. The development of the coffee leaf rods had 2 different stages, like start with the incubation period and then latency period. What happened with that? This part is the more relevant because it's the part that normally we don't see, and it's going to take between 18 days to 40 days, again, depend on weather condition, most focus in temperature. So the spores, like Lisa told this morning in another meeting, they find spores in the leaves, but they don't find germination of the spores. What happened with that? We don't know if there is any factor that inhibits the germination of the spores, but they are there. So at the beginning, we are not going to see nothing until around 20 days. This small yellow color that is very confused, like Lisa told before, with other disease, more focused with Cercospora. But 1 or 2 weeks later, we are going to see this production of the spores of the fungus. That is the major signal to see, oh, this is rose right now. And all of these depend on, again, weather condition, host plant, and the same rise of the disease. And one element as a coffee grower that is really concerned for us is normally when we produce coffee, the factor or relationship that we have between how many pounds of cherry we need to produce 1 pound of dry permanent coffee normally is 5. This is like the standard. If you are lower than 5, your coffee is great. If you start to increase higher than 5, there is some kind of situation. So when we had this disease and we don't have control of this disease, the factor could be 6 pounds of cherry to produce 1 pound of permanent, or in the worst situation, about 8 pounds of cherry to produce 1 of dry coffee. So, and this could be very, very bad for us. So weather condition, again, they are the major factor here in the how the development of the disease is going to occur. So we know that the elevation is related with temperature. That means we see more infection and severity of the disease in low elevation, and totally opposite in high elevation. We know that the temperature optimum is ranging between 60 to 83 Fahrenheit, but also there is some specific temperature for germination and to keep doing the another development of the disease. We know as well that, for example, high temperatures during summertime in some locations, like for example Brazil, could be affect the sporulation, or also kill the spores of the fungus. So all of these factors are relevant in the development of the disease. Rainfall is really critical because indirectly rainfall is going to tell you how the coffee season is going to move between production of foliage, production of flower, and production of berries. And what happened with this disease? Like Lisa told before, is totally one parasite that depends on the coffee plant. So the disease is moving in the same tendency of how the coffee plant is going to produce. What does it mean? More foliage, more production, more infection, more severity. What does it mean? We had years that we get high production, and we had years that the production go down. The disease is moving in the same direction. When we get a lot production coming, because we had more area of the foliage available for all the spores around in the air, we are expecting more infection and more severity if we don't do anything. So sun radiation is relevant for all this part of the cycle, and the winds and the rainfall are factors for dispersal as well, plus human activities. So this just to give some examples. Elevation. If you go up, the coffee leaf rods is expecting to get lot infection and lot severity. At the time you increase in elevation, the disease is going to reduce. That this is good for coffee plantation at high elevation. Doesn't mean farmers that had coffee farm in this location, they are going to be relaxed and do nothing. No, they need to be alert as well. But this is like the pattern that we see in Central and South America. Many coffee plantations that had other trees inside and produce shade, like avocado trees, mango trees, magna trees, platano, whatever, banana. So more shade you had, more infection, more severity you are expecting to in your plantation. So that means we need to do regulation of all of these shades. Rainfall, more rainfall is going to affect directly how the coffee season coming, how the plant is going to, the physiology of the plant. At the same time, when we get more rainfall, we get more infection, more severity. But something important, when we do agronomic practice, that they are control of the winds, apply fertilizer, pruning, removing of the sucker, reduction of the shade, all of these practice, they are going to help us to keep coffee plant healthy. If the plant is healthy, the plant has not too much stress. That means this plant is going to support more the infection and severity that one coffee plantation that the farmer is doing very little or poor practice. So spraying time is very relevant, and we had to make a combination between protectant products and systemic products, and had to be early during the season. So there is some question that I try to tell us, like Lisa told, she go back to the history, and it was very good. And I put here this question: when the coffee leaf rods was reported in different countries, and we had here a list of the countries from Sri Lanka, Angola, Brazil, and many places in Central and South America. And then, did the coffee leaf rods affect the coffee production in those countries? The answer is very simple: yes, and a lot. And did the coffee leaf rods cause economic losses in those countries? Yes. Now, this question that is very important: is coffee root loss still a phytosanitary insult in those countries? And the answer again is yes. But the last question, that I love this question, is: did coffee production disappear in those countries because the coffee leaf rots? The answer is no. That means we had here a very good example. The many countries that had this problem before, many years before, and still producing coffee: Brazil, Nicaragua, Guatemala, Mexico, Colombia. And we had the problem. That means we here in Hawaii, we are going to do the same. Just it's challenging at the beginning. We had to be proactive. We had to work hard, all the institutions, all the people, to address the problem, but there are solutions. So this is not like the coffee industry is going to collapse. This is one of my messages. Alternatives for managing the coffee leaf rots. So we had two alternatives: long-term solution and short-term solution. Regarding long-term solution, the point is we need to introduce, or we need to create, coffee cultivar resistant to the disease. There is more than 50 strains, and like the race number 2 is the most common in many places in South and Central America. And after they was reported, then new races were reported as well. So something that is important is when we see these species, coffee arabica and coffee canephora, they had genes that they could be resistant to some specific race, to the disease. But also there is some species of coffee that they are susceptible. Here, Timor hybrido is a natural crossing between coffee arabica and canephora, and they had the gene that they are resistant to the race number 2. So, and from this Coffee plant is when all material of the cultivar resistant to the rust has been started, the program to create all of this kind of material, coming most of them from this one. So in Colombia, only to get one idea, we had more than 2,200,000 acres land. 77% is planted with material that is resistant. We had Colombian cultivar, Castilla, Semicafe, Tabi, several. But also still we had 23% of the area with Caturra typica Bourbon, that they are susceptible. And they didn't disappear. They had to work. They need to manage it. They need to learn how to do it. I put one of the aspects is the disease try to survive. When they find a resistant coffee plant, the pathogen is going to little by little over time get genetic mutations. And this is why they had the opportunity to break down the resistance. So that means this is a solution a long term, but after 10 or 20 years after we create one material, this one could be one mutation of the another race, and again start the process. So this is something that I think never end, but still we can produce coffee. So, I don't know. Okay, there is two examples what happened recently in Colombia and Central America. If you see here in Colombia, we had the report in 1983, and we had coffee planted between 3,000 and 7,000 feet elevation. Normally, coffee plantations higher than 5,000 feet, we don't have the problem. By the way, this is one of my coffee farm in Colombia, my family coffee farm. And I remember we didn't make too much effort to control the disease because we were higher than we were about 6,000 feet elevation. But what happened when the impact of climate change is increasing temperature? Right now, high elevations in Colombia, they are facing problem of the increase of the infection and severity of this disease in material that they are susceptible. And what happened in Central America in between 2012 and 2013, that's America, they had some areas with material that they are resistant. The increase of the temperature, different distribution of the rainfall, and also the low price of the coffee in the marketing. They play a very important role because farmers, they didn't put too much attention to the practice. So was all agronomic practice done. So all of these factors together may increase the infection and severity, and they lost a lot of production in all Latin America, between 25-30%, and this is really a lot. So now, alternatives in short-term solution. What we can do right now, I just recommend 5 steps that we have to do as soon as possible. One is keep taking care of the coffee crop in the same way we are doing. Just beware that we have to control the weeds sometimes, make a program of fertilization, pruning, removing the sugar, regulation of the shade. All of these activities together, they are not going to control the disease, but they are going to make the environment more negative for the development of the disease. All of this is why they are important. So, and nutrition is very relevant. I had to be balanced in nutrition. So, inspection. I remember right now, this could be one of the most important activities. We as a coffee grower, we need to see if we have the problem, but the idea is people from the University of Hawaii or people from the Agricultural Department of Hawaii, they are expecting to take the samples to verify if there is the rust or not. Because if we try to do right now, the only thing we can do is disperse the disease in other locations. So, but inspection could be a very important aspect. So now we had to spray, and I can tell you in Spanish, my son always say, sí or sí, that means yes or yes. Yes or yes, we had to spray because we had susceptible cultivars. Now, when we are going to spray, it depends when we are going to get the disease. It depends what's going on to the next coffee season. So, but we need to be prepared for that. And Also, we need to try to reduce the dispersal of the disease as much we can. In the case we had one confirmation that we had this one in one coffee farm, please, we need to tell other neighborhoods because the disease could be spread so fast. So I like too much this picture because it shows you a healthy coffee leaf and little by little how the infection and severity is increasing at the time it's moving. And the spray program had to start in the early symptoms that we can see. And when this occurs, normally, I take this one from Colombia, we record intensity of flowering, and when we get medium or high flowering, we are going to put the day, and then we are going to make a program for spray between 45, 60 days after that. So this is why I put here at the early beginning of the disease that had to be lower than 5%, we need to start the program of prevention. This is just a sample when I had record of the flowering in KU and what could be the day for the spray. So this one is very relevant. This is one of the last slide I have, the development of the disease. Starting with 0, that is not yet, and then you get the first spores here in this graphic, and the first cycle just occur, and little by little, the second one, and the next, and the next. So then you are going to get a fast growing of the disease in your plantation if you are not doing nothing. And this goes until the maximum severity that is going to end with the foliation of the coffee plant. So here you see how the after several cycles the leaf is almost covered in high proportion. But here I want to show this one. You see here is one model. We don't have here is no control of the disease, how they could be grow up, and here is treatment of the disease with some fungicides. And I want to make this very relevant. Doesn't matter we spray, the disease is going to be there. But the good thing is if we do the spray on time and we try to keep the coffee plant healthy, so the disease is not going to cause damage enough and affect the production of coffee, but it's going to be there until we get plant material resistant to the disease. So there is some fungicide that they had authorization in Hawaii. Andrea already, she did a very good job to put all of these products in front of us on the table. And my suggestion is, I am not the person that is going to say what introduce or what no. It depends on many other people and all of the authorities and the coffee industry, but we need a systemic fungicide. And there is some example of the name. I know there is a lot of regulation regarding that, but the control of the disease using fungicides is a combination between protectant products that we already had some of them, and also we had biological that is very good to minimize any kind of the resistance from the disease to all of these products. But at the end, we need some kind of the systemic products. This is I had for everybody. Thank you, mahalo, and thank you again.
Thank you, Luiz. That was more information, and I think we're all going to be needing it here soon. So we now have time for some questions, but before turn this over to Chet, he's going to read the questions, and then we'll see if Luiz or Lisa can answer them. But I want to let everybody know that the HCA is putting out a presentation next Thursday in the morning. I think we'll probably put it up on the KCFA website so that if you go to the KCA website, you can get that information. And also that this presentation and the one we had last week has been recorded, so you could go to the KCFA website and take it from there. So I will now turn it over to Chet.
Hi there. I'm showing My screen here is showing the website to sign up for the HCA webinar. And yeah, we'll somehow post this URL somewhere to get you there. And some extremely important people will be speaking there. Hear from Kevin again and Lisa Kieth. So. You can follow along if you go down to the bottom of your screen. There's one of the buttons says chat. And if you haven't opened that up, you can open it up and follow along with me on the questions. And we will start with, I think, Jim, your question about brown spots seemed to have been answered with Lisa's pictures. Okay, I'm getting a nod, yes. Colin, how do we get rid of sick trees? Can any kind of heat be applied to the leaves to kill the CLR spores? I'll throw that up to Lisa or Luiz. And another question was, can any kind of heat be applied to the leaves to kill the spores? I suspect a flame or something.
Oh, I think if, the disease is going to dispersal in all the island. It's something inevitable. It's like COVID-19 right now in all America. So it's something that nothing we can do more than try to prepare and be protected. So the point is, more weak coffee trees, they are more susceptible to the attack of this disease. So if we are going to cut the coffee trees, thinking in eradication, maybe, I don't know, it could be right to do right now or could be too late, because we don't know how many other places the disease already they are working. So I think we need to start the program of the detection, inspection. And if we get in our coffee farm, then we had to start the program of spray immediately there and also neighborhood. But the important thing is make a plan from the next coffee season, because this season is almost over. So if we get the disease right now, we can to protect whatever foliage is available that is going to help us from flower and production for the next year. But the focus of the manager of the disease is year by year, season by season. So, and I think if we use heat, we are going to affect the coffee leaves as well, because temperature is going to burn the leaves. So I don't know, it could be reduce the spores, yes, but also affect the coffee plant.
Okay, we have a huge list of questions. I was wondering, since we only have about 6 minutes left, Luiz and Lisa, would you be amenable to me sending you this list of questions, and you can email in email, and you can email me the answers, and I will post them at the end of the video that I will put together of this presentation. Is that okay with you two?
We can
Happy to do that. Yes.
Thank you. The next question was, are there some varietals that we have?
Thank you, Lisa.
Are there some varietals we already have in Kona that are more resistant? And then there was a list Sharon and Bob shared asking. So I'm opening that up to Luiz and Lisa and anybody else who might know.
I already know there is cultivar resistant here in Hawaii, in Kona. Some of them are official cultivar. Introduced by the Agricultural Department of Hawaii, already passed through quarantine. But also, I already know there is many other coffee farms that in one way or in another way, they introduce coffee seeds from material that they are resistant. And now I think we need to try to see how resistant they could be. But yes, there is some material already.
We got a question here. Would composting just keep spores growing?
No. So again, the spores, the fungus needs living host material to complete its life. Okay, so with the destruction of the leaf material, the spores will die as well.
Okay, good question. Do we know the exact location of the infection in Holualoa?
Andrea might be able to answer that.
Only thing that I
Andrea.
can tell you is, without divulging confidential information, is that it's in the area of Donkey Mill.
My personal opinion is right now we need to respect confidential information for everybody, but right now the problem could be too serious that it's very important. All of these institutions tell the neighborhoods around this specific location that the problem is there and they need to act right now. Tomorrow could be late. This is my recommendation. I respect privacy, but this is not something that we are going to hit. Have to be in front.
A question about torching infected leaves sounds easier, cheaper, and safer than spraying 3 kinds of fungicide, is the question. Is that true? I guess is the actual question.
Again, typically, there's a lot that goes into management. Again, not one magic bullet. So oftentimes it is the application of fungicides to make sure that the fungus is killed first prior to the removal or torching of the material.
Interesting question. Lisa, you mentioned some other fungus will kill CLR. Is any work being done on using these killer fungi to help eradicate CLR?
Yeah, I wish I had better news for that. You know, it does seem like Lecanicilium species does attack it, but it is not used as part of a biocontrol program anywhere. I guess
And
it's just the contribution if it naturally is there.
We have another question. How does the spraying of fungicides affect CBB control? That sounds like a Luiz question.
Been some of the fungus already approved here in Hawaii, like Andrea had showed before. They are compatible according with the label from Bio4, the company that produces Botanigar. They are compatible with some like Koontz 3000 and others. So I think we can use it. There is another fungicide that maybe could be affect the Beauveria bassiana, but unless we had a couple of them compatible, and this is good news.
Yeah, and Andrea showed some really good charts that are in last week's video. So if you're really interested in getting the details, it's her presentation last week had a lot of information. Let's see. Since in Kona it has been found on Typica, I'm wondering about other varietals. Again, not about the ones being grown to be resistant in other countries. And then where can we get resistant trees? Good questions.
Well, I think if I can just comment, I mean, unfortunately, this is more of a long-term strategy as far as, you know, even with our agency, it's just the beginnings of having the material to start to propagate, to do testing. But in addition, you know, as mentioned, you'll constantly hear it also then the cupping quality as well. So that's very critical to things needing to taste good. You know, they can be resistant, but will they taste as good as we wanted to growing in the conditions here?
We had an answer from Andrea in case you want to check out the chat. I think what I'll do is I'll post a link to the text of the chat, which will also be saved. There are some answers to people's questions in there. Are copies of the PowerPoints presented going to be available?
Yes, we can put the material available for all coffee growers in Hawaii. I'm very happy to do that. Plus, I can put some material. It's in Spanish, but there is a lot of people, field workers and managers, they speak Spanish. And unless to get information, basic information about the disease, at the time we are improving all the material that we can put in English.
I think as long as it's on the website, I think they can, what was presented, they'd have access to, if this has all been recorded. And I think we're almost out of time here. Might have time for another question or two if you got time, Chet.
Well,
Yeah, if you don't mind, because I think we'll have the opportunity to answer questions listed. I just want to really reiterate what Luis mentioned. You know, we're really unsure where it is and to what level it is. You know, yes, people, it's very difficult to eradicate once something gets started, particularly coffee leaf rust. But we really need to be proactive in searching out your own locations to see the incidence and severity of the rust. We really do not currently have a good idea, besides the 2 positive identifications on Kona side. We have not seen symptoms, and we see a lot of pictures and are involved in a lot of samples working with HDOA and the university. So I think it really is critical to really scout and understand where the fungus is distributed and how to be as proactive as possible, and to also then be able to know the best way forward with management techniques. I mean, I just need to stress that, yes, the symptoms we've seen, but we were still unsure, even in the locations, how widespread those symptoms are. So that really is the first critical step, figuring out where it is, how bad it is, and then we can sort out how best to manage it. And I know that's no easy task. It takes a lot of searching, but hopefully with some of these additional pictures that you've seen, it will be easier to rule out some of the initial confusion of some of these other fungi, or perhaps even other nutritional deficiencies that can look, symptomatic, like they're fungi, but they're not. And also, we're here as resources. If you'd like to send pictures, you send pictures to Andrea. With myself, we're always open to have another pair of eyes looking at things. So, but thanks everybody, and I appreciate your time.
Is anybody in charge here? I'll thank Lisa and Luis for all the great information, for giving us your time. We really appreciate it. And I'm sure it's really helped people understand what we're dealing with more and get an idea of what we need to do. Good old Luis, you got to keep a clean farm, right?
Thank you so much, everybody. And again, very happy to support and help with my knowledge and my experience. I was no expert in control this disease in my country, but I had some experience working there and could be helpful.
I'm sorry, my computer checked me out and now I'm back on. I don't know what I missed on this.
We just start thanking people and waiting for you to close it up.
Well, thanks for waiting for me to come back here. So thank you, Lisa, and thank you, Luis. And all this will be on the KCFA website. So thank you for bearing with me.
Hey, thank you.
This
Thanks, everybody.
presentation. Hope you learned something. Yep. Thank you very much, Lisa.
Aloha.
Thanks, Luis.